Hello, good morning, good afternoon, good evening in this asynchronous week. So today is the second lesson. It's an introduction to HVAC systems. We are not going to explain everything about HVAC systems. I want you to become familiar with some concepts because we are going to use those concepts all over the semester. So this is the second lesson and you will hear a lot of things. Probably you don't know what we are talking about. Probably you won't understand everything, but don't worry, this is the first lesson. So you have to start hearing all these concepts and by the end of the semester you should be able to talk about them. Okay? So we are going to explain HVAC systems. And today we are going to focus on heat pumps. We have different devices or different ways to heat up or to cool down buildings. We can have gas furnaces, we can have boilers. Today we're going to talk about heat pumps. So what is a heat pump? It's a device that pumps heat. Yeah. So this is a heat pump. It runs on electricity. That's important. If we have gas furnace, it runs on gas, natural gas. If we have boilers, we can burn anything, any fuel. We can burn wood, oil, gas, whatever. But today we're going to focus on heat pumps. And remember, heat pumps run on electricity. Then there are three systems. There are more, and we can combine systems. So if we, but just for the first lesson, so we are going to learn about three different things. We have air handling units. There are air-to-air systems, the second one, and the third one, air-to-water or water-to-water systems. Let's start and let's see. So first, I'm going to explain what an air handling unit is. You will hear about air handling units or AHU many times. Every single building, especially commercial buildings, we have air handling units. It can be used for heating, cooling, and ventilation. And when the building is big enough, all buildings have air handling units. Probably single-family houses don't have air handling units. They don't need it. But commercial buildings, and even if you are now or if you are taking classes at the TDS building, we have air handling units all over the building. What is it? It's an air handling unit. It's a big box. It's a huge box. It's almost empty, and it has a few things that make airflow. And as the air is flowing through that device, through that box, we can heat up, we can cool down, or we can add or remove water or moisture from the air. So this is an air handling unit. We have an air intake for outside air, and we have an air outtake. So we supply that air, that fresh air, to the interior. And then we have a lot of things here. We have filters, because the outside air can have particles, things that we don't want to breathe, especially now. So we have filters. We have coils. Well, a coil, there are water pipes that cool down or heat up the air that goes through those pipes. We have coils in houses. We have coils in cars. So we will talk about coils, and you will hear that name many times. And then we have a fan, because we have to move the air. So we need a fan. Okay, so basically we have an intake, an outtake, and then we have coils, filters, and fans. So this is an air handling unit. We put it all together. We create like a box, and this is an air handling unit. After that, how do we supply air to the rest of the building? We need a ductwork. Okay, so we need ducts, and ducts are, depending on the size of the building, depending depending on the size of the room, but ducts are big, really big. And then we have grills, or we have something that, because ducts, usually we don't see ducts. We have a false ceiling, and we don't see this. So in our room, what we see are things like these: diffusers, grills. Okay, so this is the thing that we see. The air handling unit, it's something that it's usually on the top of the building, on the roof. Ducts are within the building, between the false ceiling and the structural slab. And then grills, it's something that it's in our room, the room where we are. If you are in the TDS building, you will see a lot of ducts. Sometimes we think it's cool having exposed ducts. Why? I don't know. But it works, it's something beautiful, and people don't complain. So we save the false ceiling, and we save space. So by having exposed ducts, we can save some money. But if we have exposed ducts have to be more beautiful than this one. So this is the typical duct, and we need a false ceiling because there are a lot of things. You see, we have ducts, pipes, there are a lot of things that we have to hide. Okay, so we have the air handling unit, then we have the duct work, and finally we have the grills or the diffusers. We can complicate the air handling unit. It's the same, but here we have 4 air ducts. So we have the supply air, we have the outside air, we have the return, and then we have the exhaust. Okay, so we can complicate the air handling unit, but it's basically it's the same concept. We have a huge box with air ducts, and we have cooling coils, heating coils, filters, and fans. Okay, so we can have bigger air handling units. They are more complicated, especially if we have 4 air ducts, and it can be as big as this. So you can see that this is a human being, and this is the air handling unit. So this is something huge. And this is a picture, a real picture. The box. This is the air handling unit, and those are the ducts, and those are pipes. Okay, so those are water pipes. So air handling units. The first thing you have to understand is, first, they are very big. Second, they are not especially beautiful. So we don't hide it. We cannot have air handling units inside the building. We can, but we need usually they are on the roof of the building because they have to be exposed to the outside air. So, but look at this. We don't see this. We have to hide it. Even if they are at the top of the building, we hide it with screens or with walls. They are exposed to the outdoor, to the outside air, but they are hidden because it's not beautiful. So they are not especially beautiful. They are very big, and we need ducts to bring the air, the outside air, into the building. This is an air handling unit. And this is the schematics. Then you have to become familiar to schematics of buildings. Here we have the air handling unit, we have the exhaust air, the intake, the return. So here that would be an air handling unit with 4 air ducts. And here we have filters, cooling coils, heating coils, we have the fan, and then we have the duct work. And this is the grill or the diffuser, and this is what makes the air get into the room, not the building, but the room itself. Then we can have a thermostat, we can have variable air volume valves. So there are a lot of things, and we will talk about this later. But basically, this is the basic unit: the air handling unit, the ductwork, and then the diffusers or the grills. Second, we are going to speak about air-to-air systems. So with air-to-air systems, what do we need? We don't need ductwork. So this is the main difference between air-to-air systems and air handling units. Sometimes we mistake air handling units, air-to-air systems, everything's alike. But with this kind of systems, we don't have, or we don't need, we can have ductwork, but we don't need it. Okay, let me explain. The most simple air-to-air system is this. I'm sure that you have seen this many times, especially in old buildings. This is the first kind of air-to-air system that we had. So in buildings that were built or designed in the 50s or in the 60s, like 60, 70 years ago, they usually had these kind of elements. Here in one unit, in one box, we have everything we need. We need something to generate the energy we need, because heating up air or cooling down air, it's not for free. It comes at a price, and this price is the energy. So we need something to generate the energy, and this is what we call the heat pump. And then we need something else to move that air that we have heated up or cooled down, and we need to move that air into the building. If everything is within a box, the same box, this is the most basic air-to-air system. This is out of date. Nowadays we don't use these kind of things. Why? Because the energy generator, it's something that makes a lot of noise, and we don't like to hear that. So when we have these kind of things in our houses or in restaurants, we see like there's a noise that we don't like. So after that we have this split system. So some people thought about it, engineers, and they said, okay, what if we split these two elements? We have something that generates the energy we need, so we place it outside the building, and the thing that distributes the air, it's within the building. So this is not noisy, or not very noisy, and the ugly, the thing that makes noise, that vibrates, okay, this is outside the building. So this is the split system, but it's the same as this. So with this element, we have two elements, and they are in the same box. With the split system, we have two elements. One of them is outside, and the other one is inside. This split system, I told you that we can have ducts. We can have. So in this case, we have the air, the outdoor unit, the indoor unit, and then we have duct work, and we distribute the air through grills. But this is not an air handling unit. Remember that an air handling unit, it's something that moves air, and it's different. There is not a heat pump in the air handling unit. But the most common split system is like this. So we have the outdoor unit and we have an indoor unit, and we have this on the wall. Okay. And well, I'm sure that in 90% of houses with the air conditioning system, we have something like that. So we have the energy generator, the heat pump outdoors, and we have the indoor unit in the room, and then we have pipes, but those pipes are, we don't have water on that pipe, we have the refrigerant, we will talk about this, okay? But these two units are connected by those pipes. So this is a split system. Why do we call this air-to-air? Because, well, here we have outside air, and we have fan, and here we have the indoor air, and there's another fan here. Okay, so we are using air as a source of energy, and we are using air as the fluid that delivers that energy into the building. This is why we are calling air-to-air systems. Okay, so remember, we have a heat pump, so we have an energy generator. We didn't have energy generators in air handling units. And this is the air-to-air system, because we have something outdoors that works with the outside air, and we have something indoors that works with the inside air. And we have highly efficient systems, and technology, it's improving the efficiency of these kind of systems. And we have this VRV, that stands for variable refrigerant volume, VRF, which is variable refrigerant flow. Okay, so we will become familiar with this, and this kind of elements improve the energy efficiency of the system, but they are all air-to-air systems. And now we have split systems. We have something outdoors, we have the outdoor unit, and we have indoor units. It can be something that it's hidden in the false ceiling. It can be something that we see like grills in the false ceiling, or we can have these kind of units that are on the walls. Okay, but this is a split system, air-to-air split system. Now we're going to talk about air-to-water or water-to-water systems. What is this? Well, it's the same. We need an energy generator. We need a heat pump. The heat pump, it's something ugly, noisy, so we have to place that heat pump outside the building. And inside we don't have something that works with air. We have a device that works with water. So the way we have to deliver the heat or the cold is using water. We don't use air. This is an air-to-air system. Now we are using water. So this heat pump is working with air, with the outdoor air, but those devices are working with water. Okay, so this is why we call this air to water. And what are these devices? We can have radiators, we can have fan coils, or we can have radiant floors. The difference between radiators, fan coils, radiant floors, we will explain it later. And sometimes it's very difficult to tell if we have a fan coil or we have the indoor unit of a split system, of an air-to-air split system. Sometimes you look at them and you can tell, is it a fan coil or is it... the only difference is that the fluid is water. So if we have a fan coil, we have water. If we have an indoor air-to-air unit, we have a refrigerant. The fluid is different. And we need radiant elements. So outdoor, we have the heat pump, and indoors, what do we have? Radiators, radiant floors, like this, and we can have even radiant ceilings. It's interesting, but it's complicated. Those air-to-water systems are more complicated than the air-to-air systems because of the water pipes. We need a lot of pipes. In my opinion, they are more comfortable. You can save energy by using air-to-water systems, but on the other hand, the installation cost of air-to-water systems is higher than air-to-air systems. So there's a balance between comfort, energy savings, and the initial cost of the system. It can be extremely complicated, especially if we have a big building. So those are radiant floors, and as you can see, well, it's cool, it's nice. The problem is that we don't see that. Then we have the floor, and this is hidden underneath the first layer of the floor. And we have all these water pipes, and if we run hot water through those pipes, we have heat. If we run cold water, we have cold. The system is complicated, and it's more expensive than the air-to-air system. Those are the radiators. So we all have seen these kind of radiators, and this is the radiant ceiling. The radiant ceiling is the same concept of the radiant floor, but we have those water pipes in the ceiling, in the false ceiling. It's even more complicated than the radiant floor. It's something very good, especially for cooling, but very complicated, and very few buildings have this. In terms of comfort and probably energy savings, this is a very good system for cooling, but it's not used because it's very complicated, and probably it's more expensive. We have seen the indoor units. We have seen the indoor units, the radiant units of the water-to-water system. Now, this is the outdoor unit. So the outdoor unit is a heat pump like this. And sometimes this heat pump is connected to a buffer tank or a water tank. Why? We'll explain this. but we have something in the middle between the heat pump and the radiant element, the radiator or the radiant floor. We can have a buffer tank like this. And then we have expansion tanks. These red elements are expansion tanks. Okay, as I told you, the installation of these air-to-water systems is complicated, and we need other elements. The split system, the air-to-air split system, it's very straightforward. So that's why in single-family houses, if we want air conditioning or a cooling system, the best option is the split one, the air-to-air split systems, because it's easier to install and much more economic. And finally, we have water-to-water heat pumps. What is this? Well, a heat pump, it's the same concept. We have heat pumps in air-to-air systems, we have heat pumps in air-to-water systems, and we have heat pumps in water-to-water systems. The difference is that we have a heat pump here. We need, because it's working with water, so the indoor element, it's either a radiator, a radiant floor, a radiant ceiling, so it's something that works with water, but the outdoor element is water as well. So we have water pipes buried, and this is what we call a water-to-water heat pump, is what we call a ground source heat pump, because it takes the energy from the ground. It has a lot of advantages from the energy savings point of view, but again, it's even more complicated than the air-to-water system. First, because you have to dig a hole, and then you have to place a lot of water pipes from this unit. So it's very expensive, it's very complicated, and sometimes you can't do it because if you don't have a lot around your house, you can't do it. Again, it's very efficient. It's more expensive, but in the long term, it pays off because we are saving a lot of energy with these kind of systems. Although the initial investment probably it's too high. And this is it. We have a device, we have a box. We don't need to split that system. So this is a heat pump, so we don't need an indoor unit and an outdoor unit. This is indoors. That's good because we don't have an ugly, noisy thing outside the building, on the roof or whatever. Those elements are not noisy, and we can have a mechanical room, and we can place that there. But then we need pipes. We need this. This is outdoors, and we need all these pipes buried in the ground. And then we need the radiant system inside the house. So if you don't want to see a lot of devices, if you don't want to lose a lot of space, and especially if you want to have a nice green roof, this is the best option. Again, it comes at a price. It's more expensive, and it's probably more difficult to install. But if you want to have a free green roof that you can enjoy, that's the best option. And that's good because by using this kind of water-to-water systems, we can combine, or we can use solar water heaters, so we can use solar and renewable energies. So that's a goal. So it's if we use these kind of things and water-to-water or ground source heat pumps, the energy efficiency increases a lot because we are using solar energy or solar devices. And we need water, and we can use this for hot water, for showers or taps or daily use. And then we need these kind of things. We need floor heating, or we need fan coils to deliver heat or cold to the building. So advantages of heat pumps. So we are talking about heat pumps. So when we are using heat pumps, we are using this direct expansion system. I will explain later what this is. So we have low installation costs, especially if we have the air-to-air system. If we have air-to-water or water-to-water, this is not true. But with air-to-air system, this is a low-cost system. Easy to test, adjust, and balance the system. Again, air-to-air systems are even easier. We don't have ceiling or wall space because we don't need ducts. Okay, so we can use, if we have air-to-air systems, we only need the indoor unit, we don't need ducts, and we are using radiant floors or radiant radiators, we don't need air ducts. Low energy consumption, the water-to-water is the best, the air-to-air is the worst, kind of. Low maintenance, yeah, it's true. There are other systems that are more difficult. So maintenance, it's quite good in this kind of systems. And this is important, individual section. We can, if we have a large building with a lot of rooms, we can have control of each room. So that's another way to save energy. We are not running the system for the whole building if only half the building is occupied. So we can just select what kind of, or the number of rooms that we are running at the time. And comfort, yeah, we have comfort because we can adjust different temperatures in different rooms, and that's important. And low noise level inside the building. The heat pump is something noisy, but it's not inside the building, so there's a noise source outdoors, okay, that's fine, but indoors we don't have noise. So we have all these advantages for direct expansion systems or systems that are using heat pumps. But we can combine things. We can combine heat pumps with air handling units. And the more things we combine, the more efficient the system will be. The more difficult and probably more expensive. But in terms of energy efficiency, and we are aiming at creating efficient buildings, so we are not here to save money. We're here to save energy. So combining different things, we can improve the energy efficiency of the system. It's more complicated, so we have to put a lot of thought into it. That is our job, and we will get paid for it, hopefully. But as you can see, we can combine different things. We can combine heat pumps, tanks, expansion tanks, radiators. So there is not only a system. So if we are working the building, we don't say, okay, only air-to-air or only air-to-water. No, we can have, especially in big buildings, we can have different systems for different uses. If we have complicated buildings and any building, for example, the buildings we are using in the campus, we have auditoriums, we have large classes, large classrooms, we have small offices. So in these kind of complicated buildings, it's good to analyze the building, and probably there's a system that it's the best for different parts of the building. So it gets more complicated, but I think it's better. And that's it. So you have seen that I have uploaded on Canvas the course syllabus and the course outline, so you have the contents of the course there. Then I have uploaded a book, and the first quiz, you have to read the first chapter of the book, not even the first chapter, it's just a couple of subsections. So you have to read it, and then you have to do the quiz. Okay, so this is the second lesson, and I will post the second quiz on this lesson. So look at this, look at the lesson, and then open the quiz, and then you can watch the lesson again if you don't know the answers to the quiz. Okay, but this is what we are going to do in this course. We are going to give a lesson, and then you will have to work on a small quiz or a small assignment to let me know that you have understood the basic concepts of the lesson.